In this video, we're going to do a few more examples dealing with exponential functions. So remember, an exponential function is a function of the form a constant times some number to the power x. So x is in the exponent. Now the I guess I should have written here, it's the growth factor, but it's also called the base of the exponential function. So the base has to be non-negative, or positive, so bigger than 0. And we take out the a equals 1 so we don't get the constant function, because the exponential functions behave a certain way and the constant function does not follow that pattern. And c is a real number. So we're going to start by doing a graph that I left for you to do. So it was to graph g of x, which is 1 over 3 to the power x. And I mentioned that you could, if you wanted to, you could use transformations. So 1/3 to the power x is the same as 3 to the power minus x. So that would be a reflection over the y-axis. Okay, so it's going to look a lot like this graph, okay, but reflected over the y-axis. So we're going to get a shape like that. Okay, but if you want, we can do it with the 1/3. Okay, so if we have our x values, okay, and then some y values, being 1 over 3 to the power x. Okay, obviously 0, anything to the power 0 is 1. Okay, so we have a point at 0, 1. If I have 1, then I have 1/3 to the power 1. Obviously that's going to be 1/3. So that's going to be somewhere over here. If I have 2, then it's 1/3 squared, which is actually 1 over 9. So I'm getting closer to 0. Okay, now I'm never actually going to reach 0 because it's a positive number to some power. So I'm going to get my horizontal asymptote over here. Okay, now if I do the negative numbers, let's say -1, then I have 1/3 to the power -1, which is actually 1 over 1/3, which turns out to be 3. Okay, so at -1, I'm actually at 3. Similarly, if I do -2, okay, it's 1 over 3 to the power -2, so it's 1 over 1/3 squared, which happens to be 1 over 1 over 9, which is 9. So at -2, I'm already at 9. Okay, so we get the shape that is just going the other way. So it's going to look something like that. Okay, so notice that it was a reflection because the negative is with the x. It's a reflection over the y-axis. Okay, now we don't have the graph of 3 over x, 3 to the x, but it looks very similar to 2 over x. It's just going to drop a bit slower or a bit faster and rise a bit faster on that side. Okay, so it's a reflection of that, and then you can see here, so if your a is between 0 and 1, like 1/3 is, the exponential function goes the other way. So instead of always increasing, it turns out that it's always decreasing. Okay, and the horizontal asymptote switch sides. Okay, so as a is bigger than, if a is between 0 and 1, then as x goes to infinity, that's when the y goes to 0. Okay, so the asymptote switches there. Then we talked about base e, so we graphed base e. So e is just a number. Okay, remember you can use your calculator to find it. It turns out to be a very useful number, but it is just a number. And I left this transformation for you to do. Okay, so we have e to the x, 3, 6, 7 and a bit. Okay, so e to the x looks something like that. Whoops. Okay, So this is 0, 1. This is 1 and e. And this is 2 and e squared. So if I do e to the minus x, okay, that's a reflection over the y-axis. Okay, so it's going to be the point at 0, 1 is going to stay, but now I'm going to have negative 1 and e and negative 2 and e squared. And it's going to look like that. Okay, and then I wanted to do that graph but plus 3. So this is a vertical, so a shift up 3 units. Okay, now remember when you shift up and down, that moves the horizontal asymptote. So it's going to be now at 3. Okay, and then instead of being at, 0, 1, we're going to be at 0, 4. And then negative 1, we're going to be at e plus 3. So that's around here. Okay, and then the at negative 2 is moved up 3 as well. So it's going to be around there. Negative 2 and e squared plus 3. So my graph has been shifted up 3 units. So you can see the transformations work exactly the same as they did with other polynomial graphs or rational function graphs. Okay, so the last thing we talked about was solving exponential equations. So if you can get them so that they have the same base, then you can say the exponents are equal. Okay, so we had a couple left to do. Okay, so here I'm going to want to simplify, but it does look like everything is using base e here. Okay, so let's simplify. So the left-hand side is e to the negative x squared. On the right-hand side, I have e, I'm going to multiply those, so it's e to the 2x times, and then 1 over e cubed is actually e to the minus 3. Okay, so then because I have multiplication with the same base, I can add those exponents. So this is e to the negative x squared is equal to e to the 2x plus negative 3, so minus 3. And now they have the same base. Okay, so I can say the exponents are equal. So the negative x squared is equal to 2x minus 3. And now I just have a quadratic to solve. So I'm going to move the x squared over. And then I want to factor. So two numbers that multiply to give negative 3 and add to give positive 2. That's going to be x plus 3 and x minus 1. So I'm going to have x is negative 3 or x equals 1 for my solutions here. Now there are different ways to do this. So I looked at, maybe I'll just do this over here. So so on the right hand side, okay, so I brought it up with a negative exponent, but you could have written it as e to the 2x over e cubed, and then you have division with the same base, so then you would subtract the exponents. Okay, it's the same, you get the same thing at the end, just a different approach. Okay, so that doesn't change anything, but you could have used division instead of multiplication with the same base. Okay, for number 6, now I don't think that they're in the same base at the moment. Okay, so I have 5x plus 3 to the power x plus 3. But 25 is 5 squared. So this is actually 1 over 5 squared to the x, okay, which is actually 1 over 5 to the 2x, which I could bring up as a negative exponent. So that side's going to be 5 to the negative 2x, and now we have the same base. Okay, so at this point, now we can say the exponents have to be equal. So x plus 3 has to equal negative 2x, and then I want to solve for x. So that means 3x is equal to negative 3, which means that x is negative 1. Okay, now you can always check your answers by plugging them back in and make sure that you get the two sides being equal. Okay, now just to remind you, right now we only know how to solve exponential equations where they are either are in the same base, so everything was to do with e's there, or we can put them in the same base. So here, knowing that 25 is 5 squared, now everything's in base 5. Okay, but sometimes we won't be able to do that. So if we had equations like this, it's not easy to write 2 as a base 5 or 5 as a base 2. Okay, so then we want other strategies to deal with ones that we can't easily put in the same base. Okay, so that's going to be coming after we talk about another function that's going to be useful to help us there.